Good morning, good afternoon, and good evening, everyone. My name is Sua Lee. Today, we'll be discussing the effects of extrusion on concentrations of metabolizable energy in corn fed to pigs. This work was presented in 2024 ASAS Annual meeting. As is well known, weaning is a particularly stressful period for piglets. Therefore, we need to make sure pigs consume their feeds for growth. However, if they fail to do it, this can cause intestinal disorders and retardation of growth, which will lead to failure to predict volunteer feed intake of pigs. This is a problem because requirement estimates are expressed with concentrations of nutrient and energy, and if we cannot guarantee the intake of the pigs, this will lead to feeding pigs with diets below the requirements. Therefore, the initiation feeding is a key after weaning. Even though extrusion is widely used for pet food or aqua feed, it can also be used in diets to enhance the feed intake of weaning pigs. The extrusion is a process where heat, moisture, and pressure are applied. During this process, starch is gelatinized and protein structures are changed, which will increase digestibility of energy and nutrients and therefore increase growth performance of pigs. However, if the conditions during this process are too extreme, then dietary amino acids can be heat damaged and it will add cost. With particle size reduction, the surface area of the particles is increased, which also increases the interaction between particles and digestive enzymes. Therefore, it may result in increases in nutrient digestibility and growth performance of pigs. However, if pigs are fed diets with a smaller particle size for a longer time, this can cause health problems such as ulceration and keratinization. Like extrusion, as this is an extra step, this will also increase the cost. It is possible that nutrient and energy digestibilities are affected by different feed technologies. Therefore, we conducted an experiment to test the hypothesis that there are interactions between extrusion and different particle size of corn on the apparent thoracic digestibility of energy and concentrations of digestible energy and metabolizable energy. 6 corn-based diets were formulated with a 2x3 factorial treatment arrangement. The first factor was the diet form, which were meal versus extruded form. The second factor was the particle size. For this experiment, we first prepared one source of corn and ground it into 3 different particle sizes, 700, 500, and 300 microns. The corn was then divided into 2 batches. The first batch was extruded, but the other batch was not extruded. Therefore, there were 6 sources of corn. Pigs were limited fed at 3 times energy requirement for maintenance. We utilized 48 pigs with an initial body weight of 12.8 kilogram, and these pigs were allotted to diets using a randomized complete block design with different weaning groups as block. After 5 days of adaptation, feces and urine were collected for 4 days. Diets and feces were analyzed for dry matter and gross energy, and urine was analyzed for gross energy. Using the analyzed values, the apparent thoracic digestibility of gross energy and concentrations of digestible energy and metabolizable energy were then calculated. We used the mixed procedure of ASAS, and the statistical model included diet as fixed variable and block as random variable. Contrast coefficients were used to compare the diet form, linear effects of reducing particle size, and the interaction between the two. Before moving on to the results, let me first set up the slides and the rest will follow the similar structure. The x-axis represents non-extruded corn diets and extruded corn diets with different particle sizes. And y-axis represents digestibility or energy concentrations. The data from this experiment indicated that there was an interaction that as particle size of corn was reduced, the apparent therapeutic digestibility of gross energy was increased in non-extruded corn, but that was not the case for the extruded corn. Regardless of particle size, the extrusion increased the digestibility of energy. Now we are looking at the concentrations of metabolizable energy in corn. There was an interaction between the diet form and particle size, showing that the concentrations of metabolizable energy in non-extruded corn were increased, but the metabolizable energy was rather reduced in extruded corn when particle size was reduced. Regardless of particle size of corn, concentrations of metabolizable energy in extruded corn were greater than in non-extruded corn. The differences in the reactions of corn with different particle sizes to extrusion can be explained by the analyzed total starch and gelatinized starch. The analyzed starch was between 60 to 61% and was consistent across the 6 sources of corn. We also analyzed gelatinized starch, and the results indicated that only 8 to 11% of the starch in non-extruded corn were gelatinized. However, after extrusion, these numbers increased to 90 to 96%. However, the percentage of gelatinized starch decreased as the particle size was reduced from 700 to 500 to 300 microns. This suggests that the extrusion is less efficient for corn at 300 microns compared with corn with the larger particle sizes, which resulted in differences in energy digestibility. In conclusion, reducing particle size of corn had a positive impact on energy digestibility in non-extruded corn. Regardless of the particle size, extrusion of corn increased energy digestibility and concentrations of digestible energy and metabolizable energy, which is likely a result of starch gelatinization in extruded corn. However, the effects of reducing particle size and extrusion were not additive, which indicates that it is not necessary to grind corn to 5 or 300 microns before extrusion. I would like to thank everyone for listening to my presentation, and special thanks to Caleb Marshall for helping us conduct the experiment.